Muller and MacDonald challenged the conventional theory for the cause of glacial cycles in 1995, according to the Milankovitch theory, where the 100,000-year glacial cycle is attributed to changes in insolation, that is, solar heating, brought about by variations in the eccentricity of the Earth's orbit. They noted serious theoretical difficulties with this concept because insolation variation are too small to drive the cycles, and a predicted strong 400,000-year modulation is not present. They further pointed out that there are specific disagreements between a strong glacial cycle at both 400,000 years and the present times when the eccentricity modulation is near zero. This conflict is also called Stage 11 problem. In addition, improved measurements have uncovered an apparent causality problem. The sudden termination of the glacial cycles appear to precede the increases in insolation. Although this interpretation has been disputed, they suggested that a radical solution is necessary to solve these problems. Muller and MacDonald propose that the 100,000-year glacial cycle is caused not by eccentricity, but by the previously ignored parameter orbital inclination, that is, the tilt of the Earth's orbital plane. Muller and MacDonald simplify the cycle intervals to 100,000 years and 400,000 years, although they vary in duration, as shown in Berger et al. For interglacials of the last 800,000 years, and in the graph presented here from a report by Cornett comparing notes between Triassic and Jurassic Milankovitch climatic cycles and Pleistocene cycles in Berger et al. 2015. In the new theory presented here, we concur with Muller and MacDonald that orbital inclination has been overlooked, but more importantly, we propose that the Earth rotates on its orbital axis, formerly Precession axis, during an ice age, but stops rotating on that axis during an interglacial period. This shift in rotation provides a unique explanation for orbital inclination and requires an additional mechanism for stopping orbital axis rotation when the Earth's orbital plane is closely aligned with the Sun's ecliptic or accretion disk. In order to accomplish this periodic transformation and alteration in Earth rotation approximately every 108,000 years, with shorter interglacial cycles of 21,600 years, a mechanism is proposed that involves a slow wobble of the Sun, such that its accretion disk regularly seesaws above and below Earth's orbital plane, just enough to free the Earth from the rotational braking caused by the alignment of Earth's orbital plane with the accretion disk. It is therefore necessary to propose an astrophysical explanation for why the physics within the influence of the accretion disk causes rotation of matter in the plane of the ecliptic to be retarded or stopped. The Coriolis force above and below the ecliptic is opposite, but cancels out movement perpendicular to the direction of rotation of the axis of rotation of the Sun within the accretion disk. Muller and MacDonald propose that the use of oxygen isotope ratios, one can determine the percentage of Earth's water that is frozen in ice. In the diagram shown here, they compare orbital inclination, solid line, lagged by 33,000 years, with delta oxygen-18 isotope climate data, note the dotted line, for the last 600,000 years from the spec map compiled from data from 5 seafloor cores. Their figure also shows the orbital inclination, I, solid line, calculated by direct interpretation of planetary perturbations, which was transformed to the invariable plane, the plane of symmetry of the solar system, and shifted to give the best least squares fit to the delta oxygen-18 data. They state that only 3 parameters were adjusted, 1 for the delay and 2 for the overall scale for the best fit. I preceded delta oxygen-18 by 33 times 3,000 years. Since this is positive, there is no causality problem. Similarly, the presence of a strong variation in I near 400,000 years solves the stage 11 problem. The existence of the 100,000-year cycle of orbital inclination does not seem to have been previously noticed by climatologists or astronomers. It may have been missed for two reasons. Ever since Milankovitch, the implicit assumption has been that insolation is the driving force for climate cycles, and insolation is not directly affected by orbital inclination. Secondly, the 100,000-year cycle is not evident when I is calculated in the usual reference frame based on the present orbit of the Earth. Only when transformed to the invariable plane or a plane near it does the 100,000-year cycle unmix from the obscuring effect of a strong 70,000-year orbital precession cycle. We note that the 70,000-year cycle has been reported in delta oxygen 18 data from other sedimentary samples, and we suggest that this cycle may be related to orbital precession. The only mechanism we have found that could link orbital inclination to climate is extraterrestrial accretion of meteoroids or dust. Such material can be detected in ice and sedimentary rock through analysis of iridium. Walter Alvarez has pointed out that extraterrestrial dust cycles could be detected using helium-3. If this mechanism is correct, then the 100,000-year cycle should be seen in ice and sedimentary records of extraterrestrial accretion. C.F. Imbrie et al., 1984 and 1993. Thinking outside the box. I've just given you the thoughts and concepts by Muller and MacDonald in 1995. Now I'm going to present a radical change in thinking about how the Earth rotates. The Earth actually has two axes of rotation, the solar axis and the orbital axis. But during Ice Age interglacial periods, there is little rotation on the orbital axis. How do we know this? It has been assumed that the present is key to the past and that the precession cycle of 25,766 years was the same during the last Ice Age as it is today. Controlling angular momentum. Controlling angular velocity on a rotating stool. As in this video clip, the man, when he holds weights in his hand out from his body, his rate of rotation slows down. When he brings those weights close to his body, his rotation speeds up. Since the changes in Earth's spin on its orbital axis are very slow, it takes as much as 7,000 years for rotation to decrease at the end of an Ice Age period. Does that mean that when the Earth's orbit is aligned and within the accretion zone of the Sun, that the mass of the Sun is added onto the Earth as if larger weights were added onto the chair spinner's arms in the video? If that is the case, then the angular momentum of the Earth would be dramatically decreased during an interglacial period when the Earth is aligned with the Sun's accretion zone. I was looking for what would happen when the Earth's orbit is no longer in alignment with the accretion zone as it is today. Would that mean that the Earth would have freedom to rotate on its orbital axis when its orbit is mostly outside of the accretion zone due to the Sun's wobble on its own axis? When the Earth's orbit is not aligned with the accretion zone, can rotation on the Earth's orbital axis change or increase? How can Earth's rotation on its orbital axis accelerate? My theory predicts that the eccentric distribution of mass inside Earth would be pulled by the Sun, thereby causing the southern hemisphere to track the Sun with the South Pole pointing inside Earth's orbit. That is, based on the orientation of the solar axis, which is tilted by 23 degrees from the Earth's vertical orbital axis. In other words, the Earth rotates on its orbital axis much faster during an ice age. The Earth would then rotate on its orbital axis one complete turn every year, like the Moon rotates on its orbital axis around the Earth. To recap, my theory predicts The Earth rotates differently between ice ages and interglacials due to the wobbling of the Sun on its own axis, which is why we have ice ages alternating with interglacial warm periods. This is very different from what we find in the geologic record. This relationship was very different before the Pleistocene period, when at least 6 climate cycles of different duration were nested within the next larger cycles. We know this because of coring in rocks 190 to 230 million years ago. Olsen et al., 1995. We know that a major change in celestial mechanics occurred at the beginning of the Pleistocene because of ice coring in Antarctica and in the Arctic Greenland that go back 800,000 years from the present. Berger et al., 2015. Another problem is the amount of ice that accumulated in Antarctica during an ice age. We know that the northern ice cap grew extensively all the way down into North America, but radar data showing the landforms below Antarctic ice provide evidence of V-shaped valleys, which are typical of tropical climates. And ancient sea maps, as presented by Hancock in 1995, show a progressive icing of Antarctica at the end of the last ice age, not the reverse. In Graham Hancock's 1995 book, Fingerprints of the Gods, he presents in his first chapter, Introduction, the mystery of the maps. These are maps from the 16th century, which show how the last ice age ended, and how Antarctica, which had been free of ice, became covered with ice, and an ice shelf developed around that island continent. He says, the combined effect of the Piri-Reis, Orontius Phineas, Mercator, and Bausch maps is the strong, though disturbing, impression that Antarctica may have been continuously surveyed over a period of several thousand years as the ice cap gradually spread outwards from the interior, increasing its grip with every passing millennium, but not engulfing all of the coasts of the southern continent until around 4000 BC. The original sources for the Piri-Reis and the Mercator maps must therefore have been prepared towards the end of this period, when only the coasts of Antarctica were free of ice. The source of the Orontius Phineas map, on the other hand, seems to have been considerably earlier, when the ice cap was present only in the deep interior of the continents, and the source for the Bausch map appears to originate in even earlier period, around 13,000 BC, when there may have been no ice in Antarctica at all. This contrast between a massive ice cap in the northern hemisphere and hardly any ice cap at the southern hemisphere is consistent with the tilting of the solar axis, with the South Pole pointing inside the Earth's orbit and the North Pole pointing outside the Earth's orbit during an ice age. That would mean that the southern hemisphere was bathed in sun as the Earth rotated on its orbital axis 360 degrees each year, and the sun rarely would set in Antarctica, while at the North Pole, the sun would rarely rise above the horizon during an entire year, and the North Pole would be much colder than the South Pole because it tilted outside the Earth's orbit during each ice age. According to my theory, the current distribution of the continents and oceanic crust favors the South Pole pointing towards the sun because the solar axis is at a 25.5 degree angle. The Earth rotates simultaneously on two separate axes during an ice age, that is the solar axis and the orbital axis. Only when the Earth's orbit is completely in line with the Sun's ecliptic or accretionary disk is the rotation on its orbital axis braked or stopped, like a spinning skater holding his arms out. That alignment occurs in a rhythm of a 1-5 beat over a 259,200-year cycle, caused by the sun's axial wobble. That is, 21,600 years for the interglacial, 108,000 years for the Illinoisan Ice Age, 21,000 years for the Sangamonian or Eemian Interglacial, and 108,000 years for the Wisconsin Ice Age, followed by the Holocene Interglacial, in which we are located in time. This chronology is based on ice cores from the Arctic, Greenland, and the Antarctic. The most important archaeological find in recent years was made in southeast Turkey. A circular temple was discovered called Gobekli Tepe and dated to the end of the Paleolithic period, that is 14,000 years before present. It was not regarded as a solar equinox and solstice observatory, although its construction indicates it was an astronomical observatory. National Geographic, June 2011. What were the builders of Gobekli Tepe measuring? They built numerous circular observatories. Why did they need so many? If the Gobekli Tepe builders were recording the time when a complete year had passed, as the Earth began slowing down on its orbital axis, based on one complete revolution of the planet on its orbital axis, as the Earth slowed down in transition to the Holocene Interglacial, the number of extra days that had to be added onto the revolution to get alignment of a mountain peak with a star or constellation would be measured as an angle or portion of 360 degrees. The posts around the inside of the circular walls may represent those directions where yearly alignment occurred. 30 degrees would equal 30 days short of 360 degrees full circle rotation. Because of local difficulties and events that interfered with those people gathering to cut and move more stone pillars into place, some alignments were off and some observations were not made, that is, gaps in data. Observatory C, which was the first one excavated, represents about 23 years of recording. Overall, this effort enabled these people to predict animal migration times for hunts. According to my theory, the oldest solar equinox solstice observatories, that is, Gosek Circle in eastern Germany and Gigantesia Temple on Malta, were built 5,000 to 6,000 years ago, only after the Earth stopped rotating on its orbital axis. Some of the temples built before 6,000 years ended up having to be realigned later on, preserved in their foundation kinks. The precession of the equinoxes has a cycle of 25,776 years, quite different from the geological cycle of 21,600 years, and has been attributed to the rotation of the entire solar system. See Cruttenden, Precession Paradox in Forbidden Science, 2008. Rotation is opposite in direction for these two very different precession cycles. The zodiac rotates counterclockwise as the solar system rotates clockwise. The zodiac rotates clockwise as the Earth rotates counterclockwise on the orbital axis during an ice age. In part 2 of my Ice Age theory, I will show the influence of our moon in creating 20 to 21 cycles of 5,140 years each within the 108,000-year Ice Age cycles, and how oceanic megatsunamis were created by rapid ice cap melting during and at the end of the Younger Dryas interval, recorded by the ancient Egyptians in the Book of the Dead, Descent of Osiris into the Underworld. I find it amazing that Egyptologists, geologists, and climatologists have missed this depiction of Osiris in descent as a scientific graph that was passed down to the ancient Egyptians from the first time, or Zep Tepi. I show a simplification of that graph without the mythological implications in this diagram depicting how the Earth's precession decreased following the end of the last ice age and where solar equinox solstice observatories were first built and their relationship to the slowing down and stopping of the Earth rotating on its orbital axis. During interglacials, the Earth's rotation on its orbital axis slows down to 25,776 years. That is because the Earth's orbit is currently aligned with the Sun's ecliptic and is off perfect alignment by only 0.01 degrees. Astronomy Today, 2014, Appendix 3, page A5, Table 3A. The Earth's rotation on its orbital axis, precession axis, is braked by the Sun's north-south equatorial forces within the accretion disk. That braking of rotation perpendicular to the ecliptic allows clumping of fine matter to form planetoids and planets during the formation of our solar system. That is why there are 4 seasons in opposition between hemispheres during interglacial periods. That means the precession of the equinox, as measured today, is not constant, but cycles in length 4 times over a 259,200-year period, from 1 year during an ice age to 25,766 years in the middle of an interglacial, which is where we are today in our Holocene Interglacial. However, during an ice age, the Earth's orbit is not aligned with the accretion disk, allowing the Earth to rotate freely on its orbital axis. Then the Sun's gravity can pull on the Earth's mass eccentricity, or uneven mass distribution, causing it to rotate once on its orbital axis every year. That is because the Earth's mass, like that of the Moon, is not evenly distributed, and the Earth's core is closer to the South Pole than it is to the North Pole. The Northern Hemisphere contains most of the continents, and it's called the land world, while the Southern Hemisphere contains most of the oceans, and it's called the water world. The Earth's oceanic crust is much thinner than the continental crust, varying between 2 and 5 kilometers thick, while the continental crust varies between 40 kilometers and 70 kilometers thick, meaning that the Earth's core is on average further away from the surface in the northern hemisphere than it is in the southern hemisphere. In addition, the Earth is pear-shaped, with the southern hemisphere bulging more than the northern hemisphere because of the eccentric location of its core, which makes the southern hemisphere, the South Pole, want to point inside the Earth's orbit during an ice age. Because the solar axis, which determines night and day on Earth, is oriented 25.5 degrees from the orbital axis, which is vertical, it is not affected by the forces in the accretion disk, and its rotation within the accretion disk is not braked or slowed down. However, the orientation of the solar axis to the Sun is controlled by how the South Pole is pulled closer to the Sun by the increased mass of the Southern Hemisphere. That means the South Pole will preferentially point more towards the Sun and be inside the Earth's orbit all the time during an ice age, while the North Pole will be outside the Earth's orbit, pointing further away from the Sun. That is why the North Pole cap grew so enormously, while the South Pole cap vanished. Hapgood in 1955 speculated that the Earth's crust could slide, and Antarctica was 17 degrees further north to account for the warmer climate and loss of ice during the last ice age, which was primarily a northern hemisphere event. However, if the Earth turned on its orbital axis and the South Pole pointed towards the Sun during a yearly orbit, Antarctica would be closer to the Sun and be up to 17 degrees latitude closer to the Sun. No crustal shift in latitude would be required as proposed by Hapgood, 1955. In other words, you do not need crustal slippage and actual physical movement of Antarctica closer to the equator by the orientation of the solar axis pointing towards the sun, you would have those insolation requirements met. The sun would not set in Antarctica during an ice age. That landmass was called the land of Punt by the ancient Egyptians, and they said that the sun never set on the land of Punt. Hancock, Fingerprints of the Gods, 1995.